Okay, yeah, dividing by 3, and you get 5/9.
You take out the 3, just divide by 3.
Well,
I'm not about to put it on the outside.
divide the top and bottom by 3.
Yeah.
3's cancel each other out. And then what's x squared divided by x?
X.
X on top. And then what's y divided by y to the third?
Y squared? No. Yeah.
Well, it is. It's y squared, but it's on the bottom. Because basically what's happening is one of them cancels out, but there's 2 left on bottom. So it is subtraction, but if there's more on bottom, then it's left over is on bottom. Now they say on the directions to list the excluded value. I'm not going to make you guys do that, but on number 1, you know what values that we cannot use for x and y? X cannot equal 0 and y cannot equal 0. Why can x and y not be 0 on number 1? Right, because if you plug them in the denominator, the denominator would be 0, and that's a no-no. But I'm not going to make us do that part, I just want to mention it. We'll stick with this. Number 3. Okay, how am I going to reduce number 3? The word I'm looking for starts with an F, factor. So if it looks like it can factor, you're probably supposed to factor. How can we factor and there's 3 ways of factoring. Maybe I should write this down. It's been a while since we did this chapter. The first one is take stuff out. And you should always check that one first. Does anything go into all the terms? And if it does, we put it in front of parentheses. The second way we learned is 3-term factoring. This one shows up the most. It's like reverse foiling. 3-term factoring is setting it back up as a foil kind of thing. And the third one is difference of squares. Square minus the square. Like, for example, 4x squared minus 9. These are squares because they both have square roots. What goes into 4x is 2x and 2x. What goes into negative 9, minus 3, positive 3. Anyway, if you know those 3, you should be good. I think way back when we did that chapter, we also did a little bit of grouping. But it's not very common, so you don't have to worry about it. All right, number 3, on the top, what can we do to the top? Take out a 3. Now you can't just throw the 3 away, you got to put it outside of parentheses. What's left if I divide both those terms on the top by 3? X plus 5. If I multiplied the 3 back into the parentheses, it would go back to 3x plus 15. But I don't want to do that. I want to keep it like that. Okay, on the bottom, what do we have on number 3? Square minus a square. So, what goes into x squared? X and x. What goes into negative 25? Positive 5, negative 5. Okay, you can only reduce factors. You can only reduce things that are multiplied. That's why we have to factor these. Because multiplied values, like the parentheses, when you're dividing, multiply and divide, they cancel each other out. That's why you have to do it. Anyway, x plus 5 cancel out, and we're left with 3 over x minus 5. Remember that you have to think of x plus 5 or x minus 5 as one thing. A multiplied thing can cancel out, but if there's a plus or minus, it's just one, think of it as one thing. Okay, number 5. Can we factor anything on number 5? What's the difference between number 3 and number 5? Yeah, number 5 has 2 separate fractions that we're multiplying together, but whether it's in one fraction or 2, the rules are kind of the same with multiplying. Anything on top can cancel out with anything on the bottom. How can I factor 2x squared plus 6 over there? How can I factor the 2x squared plus 6 right here. Take a 2 out. And then when you take a 2 out, there's what left? Whoopsie. X squared plus 3, right? Does x squared plus 3 factor? No, I can't take anything out. It's not 3 terms. It's not a square minus a square. It's a square plus a not a square, but none of those work, so no, I can't do anything. Okay, now let's start crossing stuff out. What can I cross out here? 4 and 16 reduced to 4 and 1. The 1 kind of doesn't matter because 1 times whatever is whatever. Anything else? There's something else. No. X squared plus 3 you got to think of as one thing. That's a factor. That parentheses is one factor. The 4 and the 2. You can reduce inside the fraction itself. You don't have to go crossways. 4 and 2 reduced to 2 and 1. Okay, so what do I have left on top?
X over 1 times 2 over x squared plus 3.
2x. What do I have left on bottom?
No, I didn't multiply it.
Multiply.
I thought you wanted us to.
At the bottom. Here's how you get to the top. Yoink. Alright. Okay, just as a reminder, on number 6, what do you do when you're dividing? You gotta flip the right one, and then it becomes a multiply problem after that. So, anyway, number 7. Multiply. Oh gosh, I'm writing all these down. I feel like I need the visual though. Alright. So the top left is 3-term factoring, right? So it's what goes into x squared, that goes in front, x times x. What goes into 6, multiplies into 6, that would add up to negative 5.
6 and negative
6 and negative 1 multiplies to negative 6. So we can't use 6 and negative 1. Unless they put a negative 6 right there. But yeah, we have to use 2 and 3 instead. So negative 2 and negative 3. Multiply to positive 6, add up to negative 5. X is too simple, can't do anything. What, can I do anything on the upper right numerator over here?
No. I'll take out.
Take out a
X.
x. That exponent doesn't count as a normal 2, you can't take it out. But you can take out an x. If I divide both of those by x, I'm left with x plus 2. They both lose one of their x's. Can I do anything to x minus 3? No, it's too simple. Okay, now I'm ready to cross stuff out. We'll cross it out. Anything else? Anything else? No. So we got x minus 2, x plus 2 over nothing. So I'm just going to put x minus 2, x plus 2. Did I label this? 9.
That was 7.
What?
Wait.
Oh yeah, you're right. It was 7. Number 9. Same thing as we just did, except for we're going to flip the right fraction. So I'm not going to copy down exactly what they put. I'm going to go ahead and flip it so we don't get confused.
Can we take out the 3 on the right side?
Okay, we can take, yeah, I haven't done anything yet. We can take it 3 out right there. What? Okay, let's start up here though. What can I do to the top?
Take out a 5.
Take out a 5. Divide both of those by 5, we get x minus 3. can I do to the denominator
Take
over there?
out a 3.
3 and x.
3x.
And if I divide that by 3x, I'm left with x. 9x divided by 3x is 3. Can I do anything over up to this guy?
The 3's cancel out.
I mean, can I factor? No. Okay, now we're ready to cross out already. What crosses out?
X minus 3 and x minus 3. 3x and 3, no. Yeah, 3x and 3x.
Okay, let's go. 3 and 3. X and 1x. So that's going to leave 1x on top. Anything else?
So those are just x plus
5x.
5x over x plus 30. Do those x's reduce? No. No, they don't. Let's set ourselves a goal. How far should we get today? Let's go to
47.
15 maybe today.
Yeah.
Maybe you have time to do a couple evens. Some of you probably already did a couple evens. Naughty people. Number 11. We did a couple of these. They look a lot more confusing than they actually are. Do you guys know how to do 11?
Multiply by the bottom. No.
Okay, it's like a minus b over 2a divided by, so it's really like the last problem we did, number 11 is. So, do you know what I'm saying? Do I need to write it out? Please. Okay. Did you just say that?
No, I don't actually understand, but you probably did.
Okay, I'm just going to rewrite what they said in a more clear fashion. Okay, I'm rewriting the problem. Okay, do you see how I got this from what they wrote?
Yeah.
I just turned that middle division bar into a division sign. So really all we need to do is this times flip this upside down. So it looks a lot worse than it actually is. It looks confusing, but it's the same as the last one. So really what we're doing is that. Yucky. All right, can I do anything to a minus b factored?
No.
No. 2a,
No.
6ab,
No.
a squared minus b squared,
Yes. Square minus a square.
what goes into a squared?
A and a.
What goes into negative b squared?
Positive b and negative b.
So you can cross out the b.
So that's this, we've replaced this with this. I'm just not gonna rewrite it. Okay, what crosses out?
A minus b, sorry.
Anything else?
2a and you can take this.
Okay, 1a.
And 2.
Okay, I'm gonna explain this one more time. I don't know if this is gonna help. The reason these a's can cross out is because they are multiplied things. And divide and multiply cancel out. Because this means 2 times a. So these are free to be canceled out. This is a minus b times a plus b. A minus b is multiplied to this. So anyway, 2 and 6 reduced to 3 and 1. What do I have left on top?
3b.
3b. What do I have left on bottom?
A plus b.
Yay. See, that part of the chapter I think you kind of like. I mean, that's not bad, is it?
No, it
The
makes
problem is, after this chapter, last week we started doing adding and subtracting, and that's where
That was not.
we got into some muddy waters.
Just because I'm brown.
Yes, it's all about you.
Yeah.
All about you. Baby. Okay, so 13. What the heck? Any bright ideas?
No.
13, gonna get, what's the word? Like the denominators the same on the bottom thing so we can add them together. And then we're gonna flip it
Yeah.
upside down so we can do it with the 2.
Yeah. Oh, 12's like this one too, isn't it?
Yeah.
Okay. I don't think we actually did a 12 and 13 back in the homework, but we probably should have. So, we're gonna we're gonna put the denominators together, the 1 over x plus 1 over y. We're gonna put that together, and then it's basically a problem like number 11. Okay, but first we need to do 1 over x plus 1 over y. Okay, so even though this is kind of a division problem, we kind of passed into the addition territory, which is a little scarier, right? So when we're adding or subtracting fractions, we need a
Common denominator.
common denominator. So what do x and y go into?
XY.
xy. What do I have to do to this first fraction to turn the denominator into that?
Multiply by 1 over
Multiply
y.
by y. Whatever you multiply the bottom by to keep it equal, the fraction the same, you have to multiply the top by the same value. What do I need to multiply this fraction by? Ooh. Okay.
So it's just 1xy.
No, that's multiply. That's multiply. So now we switch to adding. So the top is y plus x. 1y plus 1x, or just y plus x. The book likes alphabetical order, so they probably put x plus y. But y plus x is fine. Okay, that is just the denominator. What I left out was there was a 2 up there, up here.
So now we're gonna,
Okay, that was just the denominator. Okay, now it's a problem like number 11. It's 2 or 2 over 1 divided by this. So let me rewrite it in a way that looks more easier to read. It's 2 divided by this. So what do we have to do? Flip this guy and multiply.
So what happened to the 2 on top of the xy?
Right there. 2 divide, I turn the division bar into a division symbol. It's 2 divided by this thing. So it becomes 2 times xy over x plus y. Does anything cancel out?
Nope.
No. You might be tempted to right here, but remember you got to think of x plus y as one thing. So no, it does not cancel out. So the top is 2xy, and the bottom 1 times x plus y is x plus y. So on number 12, I'm not going to write this down, but I want to talk about it a little bit. What the top is ready to add together already, because the top already has a common denominator. So what does the top add together to become? 4 over x. It's just 1 plus 3 is 4. So it's 4 over x. The bottom needs a common denominator. On the bottom, what's the common denominator going to be? X squared. So the right fraction, the 2 over x, needs to become something over x squared. So you need to multiply that one by x, so it becomes 2x over x squared. So the top, I lied, I write it down, was 4 over x. The bottom is 5 plus 2x over x squared. This is not the answer, but how do I set that up to solve? I need to do 4 over x times what?
x squared over 2x plus 1.
Okay, and that's not the final answer, but it's pretty darn close. You're getting very close there. There's got one step left. All right, number 15. So 15 is kind of the transition point. They're starting to transition to the plus and minus problems. Adding, subtracting. How do we find the least common multiple? This is where it got painful last Monday. Between 2x squared plus 20x plus 50 and x squared minus x minus 30. So if I see something like this, I should probably immediately think what?
Most.
Factor. Okay, yeah. When you're finding the least common multiple, you have to use the most of each kind of factor. Yeah, that's true. But anytime you see something that looks like this or that, like a 3-term, you probably should think it's factoring time. Oh, yeah. So what goes into x squared? X and x. What multiplies into negative 30 that could add up to negative 1?
Negative 6 plus 5.
Negative 6 and 5. Okay, what should I do first on this guy over here?
Take a 2 out.
Yeah.
Take a 2 out. You should always check, can I take stuff out first? Number 1. And yes, you take a 2 out of all those. Divide all those by 2. That stuff in parentheses looks like it should factor again.
5 and 5.
What goes into 25? Multiplies into 25, that adds up to 10.
5 and
5 and 5. Okay, to find the least common multiple, we're going to use the most of each kind of factor. So what's the most of my 2's? 1, 2. What's the most of my x plus 5's? 2. So I'm just going to write it like this, x plus 5 squared. So we didn't use 3x plus 5, just comparing the two, who has the most, the guy on the left. So we're going to use the 2 on the one on the left hand. And what's the most of my x minus 6's? 1. That's the least common multiple.
I understand how to do this, but like, why do we do
You would do these kinds of problems. This would be like how you set up for the denominators on adding and subtracting. It's like the next problem is you need a common denominator. Like, so if these were the denominators, this is how you find a common denominator.
Okay.
And it would tell you what you need to multiply the top by. We'll get into that tomorrow. Tomorrow we get a full day of class, so.